Okay, so traditional strip foundation, what is likely to be your first drawing detail of fixture. At this point you will have covered the topic of foundations in quite a bit of detail, so you will know the different types of foundations, the function of a foundation, and also all of the components involved in building a traditional strip foundation, the function of each component, and the material used in each component, for example concrete and stones for your hardcore, and sand and insulation, and so on. So at this point it's just a case of getting the detail drawn up to the correct size, the correct scale, and just to a neat and tidy standard of presentation. Alright, so we'll make a start. Okay, so as always we make sure we have a well presented page, your border all the way around, a neat and tidy title box, your name, the name of the drawing, traditional strip foundation, and your scale, 1:10. Equipment we're using, your T-square, your 45-degree set square, our 60-30 set square, a 2H pencil, a H pencil for your dark work. Just for the sake of the video I'll be using a HB, which will be a little bit darker, rubber, and your pens, red, black, green and blue pens for your Baydon barrier, DPC, and so on. Okay, so we'll make a start there. As we always say, when you're working on a detail like this, it's always good to start as if you're building it, so there's no point in building the wall if you haven't got a foundation. So we will start at the bottom, and we will start by drawing up this rectangular shape which represents the concrete strip, which is essentially the foundation part of it. The standard size of a concrete foundation is 1050 millimeters by 350 millimeters. We're working at a scale of 1:10, so every one of these measurements that you see on this needed to be divided by 10. So when you divide 1050 by 10, we get 105. When you divide 350 by 10, you get 35. So we need to draw a rectangle, essentially 350 millimeters by 105 millimeters. We're going to start nice and low, so there's the bottom of my page. I'm going to zoom in here a nice bit. We're going to start nice and low and central on the page. I'm going to pick a point fairly low, as I said, and I'm going to draw a random line. Everything we do early on in this drawing detail is drawn lightly. For the sake of the video, I'm going to go just that little bit heavier so you can see it. There's no set distance on that line yet. I'm going to just use that to guide me and to start me off by drawing this foundation. I'm going to pick a random point on that line. I'm going to set 0 on that point, and I'm going to mark 105 millimeters. 105 sometimes catches people out, so there is 70, 80, 90, 100. 1, 2, 3, 4, 5. 105 is there. Okay, I'm going to draw two vertical random lines lightly, no particular height. Again, I'm just going a bit heavier for the sake of the video. I'm going to set 0 on the bottom corner of that line there now, and I'm going to measure up 35, which is 350 divided by 10, and I'm going to take that point and draw a line across there. And that basically is my rectangle for my concrete foundation. I'm going to rub out these lines now to avoid any confusion. In your case you should draw them so light there's barely a need to rub them out, but by all means rub them out if you need to. And there. The symbol for concrete is just simply 3 random little triangles with some dots around them in a couple of places on the foundation itself. Okay, now next thing we're going to do is we're going to start to build up the concrete wall on this foundation. The concrete wall, it's a concrete cavity wall which we learnt about. It needs to be central on this, so we can't just draw it randomly over here or over there. This wall needs to be central, working its way up from the foundation. The handiest way with this standard foundation to do that is from the side, measure across 35, and that should leave us with 35 there. The position of my wall is going to be between these two dots here. The external block of my wall is 100 millimeters divided by 10, just gives me 10 millimeters, and the internal block is the same, 100 millimeters divided by 10, we have 10 millimeters. So essentially I've got 10 millimeters there and 10 millimeters there. 2 random vertical lines, lightly drawn first. How high up do I go? Just go well up the page. and have to reiterate constantly, these are light lines. Now at this point I'm going to start drawing up some blocks to mark off some blocks positions. The correct size of a block is 225 millimeters high. When we divide that by 10, it gives us 22.5. So it's a slightly awkward one, so do your best to get 22.5. I'm going to mark that off a little bit. I'm going to mark off 22.5 all the way up. Approximately 7 blocks should be enough to get us this full drawing done, so roughly 7 or 8 blocks we want to mark off here. Further up so we can see. Okay, so to mark those blocks in, we're going to go 1 block, 2 blocks, 3, 4, 5, 6 and 7 blocks. That should be enough to get us out on this drawing detail. So what we have is the external set of blocks. This is outside, this is inside. So external leaf, internal leaf, that's our cavity there. We're going to put some insulation into that later on in the drawing. Okay, now next thing that we're going to do, let's go to our solution here. The next thing that we're going to do is we're going to work down all of these components here. So we've got a concrete subfloor, we've got some insulation, rigid insulation, we've got sand blinding and radon barrier, and we've got some layers of hardcore. On top of the concrete subfloor, this is not always the case, but a sand cement screed can be poured, which is basically a finer and smoother type of concrete, cement almost, whereby you get a better finish. So often on top of the concrete subfloor they might pour a thin screed. We'll do that at the end. Our main focus is working from here down. There's room for variation on this, but I always say a good way to do this is to just count up 4 blocks, draw a line across, and work your way down with the components. Alright, so we'll do that here. 1, 2, 3, 4. Draw a line across. No particular distance, so don't overthink that distance there on that. Just go over plenty of space. And from there, I'm going to build down these components. The concrete subfloor, first of all, is 150 millimeters. We'll mark that down. It's 15, so 1.5 centimeters. Again, we've got to re-emphasize these are all light lines that we're drawing. Underneath that, we have 100 millimeters of insulation. Divided by 10 is 10 millimeters. Underneath that insulation, we have 40 millimeters of sand blinding. Well, actually under that we have the radon barrier, but we'll put that in at the end. And underneath that sand blinding we have a number of layers of hardcore. Now what we'll do with the hardcore is we're going to come up at a random angle here, so don't even overthink that angle. Randomly draw a line roughly that size and go across. Lots of room for variation on this, so don't overthink that. Something similar to that is fine. The hardcore is compacted into layers of 150 millimeters, so I'm going to, from there, I'm going to measure down 150. Draw a line across, measure down 150, draw a line across, and we'll get one more layer, and 150 there, and draw a line across. And there's a little bit less than 150 there, but that's okay. Now, looks like a lot of random lines, but each of those sections are taking up a component, a very important component of this drawing. One more thing is up along the side here we have a thinner piece of insulation which just adds to the thermal properties of this particular building. So now we'll add in the symbols for all of these so it'll make more sense. Concrete subfloor, 3 triangles and some dots around it, a couple of random places. Our rigid insulation is represented by this symbol. Sometimes these symbols can take a bit of time make sure you're neat, but if you're in an exam situation, just make sure that you're working swiftly enough through this simple work. So 45-degree set square. Just for the sake of this drawing video, I'm not going to go all the way across with this, but you would be expected to go all the way across. I'm going to stop there. And then the same, which brings up the symbol for rigid insulation. Okay, this is a rigid insulation up along here as well. Okay. Sand lining is simply just represented by some dots. And we all know the function of that sand lining is to stop the hardcore from piercing the radon barrier. And we have our layers here now of hardcore, so we'll use the 45-degree set square once again. A nice big enough gap between each of these hatches. Don't overthink the size of the gap too much. And that's each of the layers of hardcore in place as well. At this point we'll just go over to this side, the outside part. Often there's a step up into the house, so we'll go down one block. That can vary. We'll draw a line out to the left, don't overthink how far out we go, and that's just going to be soil outside the house, or maybe footpath, but we'll just represent soil by some random hatch lines along the edge, along the top, and down the edge, like so. Okay. What we need to do next then is our concrete screed actually on top of the concrete subfloor. Concrete screed can vary in size, usually 60, 70 or 80 millimeters. We'll just go in between and we'll draw a 70 millimeter concrete screed. Basically tidies up the whole floor, gives it a much smoother finish, and some dots are fine to represent that as well. Inside the cavity wall down below, so the rising wall is what rises from the foundation up to the ground level. There's a lot of pressure coming on this wall from the soil and from the hardcore. It can very easily buckle here, so what is done is some concrete is poured roughly around to the height of ground level, and that just adds support to the walls to stop those from buckling in this area. There's not as much pressure on up here, so it's not needed. Our insulation, so our cavity wall insulation, this is inside, that's outside, as we keep saying. The cavity wall insulation is on the inside, it's tight up against the inside, it's held in place by wall ties, and we can start that insulation down nice and low. We'll start it there. It's 100 millimeter insulation, so I'm going to measure across 100 millimeters there, draw a line across and go vertically up here. And again, it's rigid insulation, so I'll do some of the single work. I won't do it all just for the sake of the video. When you're doing your own drawing, you would be expected to do the full thing. There. Okay, so some of the plaster, On the inside of your walls in all your homes, you'll have more than likely a 12mm plaster, internal plaster. That is the work of the plasterer. Tidy up the wall there. On the outside, it's known as a slightly rougher, more cementy mix. It's called a render. It's usually about 18mm, and that is on the outside of most of your houses, I'm sure. So we've got a render on the outside to tidy up the blockwork, and an internal plaster, a smoother internal plaster on the inside. Last thing to do before labels is some of the pen work. So radon barrier needs to be drawn in. As we said before, the radon barrier will use a red pen. It runs along the top of the sand lining. It must be on the top of the sand lining. If the radon barrier, that's the function of the radon barrier, of the sand lining, to stop the radon barrier being punctured. If your radon barrier is resting on top of hardcore, it's going to get pierced, and that will allow potential for that poisonous radon gas to enter your house. Now a nice clean line, so make sure it's nice and visible. Go over it a few times if you have to. Clean visible red line. Radon barrier will run up along to a joint in the joint in the blocks. That one's a bit too low, so we'll go up to the next one. Across through that joint, down the inside of the wall, and out across the cavity and across there. Sometimes you might see situations where that radon barrier comes up and across like that. Either is fine. That's completely acceptable in that way. DPC with black pen. The first block above ground level, we have our DPC, which is rolled out at the joint, and that is there to stop rising damp coming up through capillary action up through the wall, which is something that needs to be avoided at all costs. Alright, so now at this point it's just a time to label all parts of the drawing. I always say it's important to be neat and tidy with your labels. Sometimes you will often see well done drawings ruined by bad labeling, because labels are just sprawled out at all sorts of angles and messy scrawly writing. So I would always say pick a section for different parts of your labels and be neat with the writing. Block capital letters, include your sizes and the name of each component. So for example, all of these components, we're going to take a line up and label them up here. These wall components, we'll use this space over here. The foundation will just label down here, and maybe one or two bits can be labeled down here as well. So I'll start up here. Okay, so I will take a line up for a couple of these components. I'm going to come up first of all for the nice line up for the hardcore, a little dot on the end of the line. I'll go to the sand blinding. The radon barrier. The rigid insulation, and the concrete subfloor. Alright, each of those have a little dot on the end of it, and we'll put in those marks. So the first one, 150mm. Oops, excuse me, not 1500. 150mm layers, capital letters by the way, of hardcore. Sand lining, 40mm. Radon barrier. $100mm rigid insulation, 150mm concrete subfloor, we'll just go over here then to label the screed, which will be completely fine. 70mm screed. Okay, I'll just come down here now and I will label the foundation itself. So I'll just write in first 1050 by 350 concrete foundation. into that. And then I'll use this area up here to label the components of the wall. So what we'll do is we'll take out a line for each part. So the external leaf, external block leaf, the insulation, cavity, the internal leaf. We'll do that much for the moment. Alright, so we have 100mm internal block, 100mm cavity insulation, cavity, 100mm external block. We can include the DPC just there, and we could include an 18mm render, external render. While we're at it there, we'll include the 12mm internal plaster. Okay, so as many labels you can get in there always looks good. Nice and well specified and well presented. One or two more little bits. We'll label this concrete infill. I will just label this as soil. Let me just bring the label up. I'll label down here. It's representing soil. And this line here is known as the ground line. And the symbol, the correct symbol, is a G with an L over it. And that represents ground level. Okay. And at that point, that drawing is complete. All proper presentation, proper sizes, and scale to 1:10. Okay.